So now that we've talked about recursion a little bit, and now that we've talked about how recursion might be implemented computationally, I think it's a good idea to actually try to implement our factorial function in code. So let's make a C file. So we're going to be coding this up in C. I'm going to start by including my input-output library, and I'm going to make a main function. So I'm going to say int main, and I'm going to have it take void. And I'm going to have main return 0. Okay. So our starting point, of course, we need a function. So we need to have a function that returns an integer. It's going to be called fact for factorial, and it's going to take an integer n. Oops. And I'm just going to put the signature up here because I'm going to actually define the function just below main. Okay. And here, how do we do this? But if you remember from last time, what we said was that we had 3 stipulations. We said that if n was less than 0, we return a sentinel value of -1. We stipulated that if n was equal to 0 or n was equal to 1, we return 1. And finally, we stipulated that otherwise we should return n times the factorial function of n minus 1. So this is n times an easier version of the problem. So let's kind of go about filling these in. So we say if n is less than 0, we simply return -1. And here we say else if n equals 0 or n equals 1, we return 1. Okay. And finally, we say otherwise, or in C the keyword is else, we say else, we return n times the factorial function evaluated at n minus 1. And I like the convention for multiplication where we don't leave a space, so I prefer to not leave a space for multiplication, but we leave a space for subtraction. I find it easier to read that way. Very good. So we've defined our factorial function. All that remains is to test it. So I'm going to write just a little small test. So I'm going to, here, we're going to start by reading input. Then we're going to compute the factorial. Then we're going to report the factorial. Okay. So 3 phases. We take input, we do some calculations, and we write a report. So we're going to say printf. This is the C standard library function for printing to the screen. We say please, or just say enter an integer. Note, I don't say a positive integer because we have written our function to return a sentinel value in case we get something that we don't want. Or actually, maybe if we just say, please enter a positive integer, and we'll do something interesting with that sentinel value in just a moment. So we can't just do that. We can't just do that. What we have to do is we have to read. So we're going to say scanf, which is one of the C standard library functions for reading from the standard input. We're going to say %d because that's the format specifier for a decimal integer. And we say %d, and let's say n. And we're going to say and n because we want to read into n, so we need its memory address. And so, of course, we have to define an integer n. Good so far. Now we're going to compute the factorial. I'm going to say we have an integer called answer. So ans is equal to the factorial of n, because we've worked out what we've read n from the user. Now we're going to compute its factorial. And of course, we need to write int ans. answer is an integer. And please note I'm using the kind of pre-C90 C99 convention that we put all of our variable declarations at the top of the function. It would be nice to initialize them at the same time, but notice we actually kind of use them once before we do anything. So here, the first time we use answer is actually an assignment statement, so there's no need to initialize answer. And the first time we use n, we're actually reading into it from the standard input, so there's no need to initialize n. And finally, we write a report. So we have to account for the fact that we may have been given bad input. So we say if we got our sentinel value, so if ans is equal to -1, we say error can't compute the factorial of a negative number. Please also note I've not ended this with a new line. I've not terminated this with a new line because I want what the user enters to appear directly after the prompt. So finally we're going to say else. Otherwise, well, we just report the factorial, right? So we're going to say printf, and the symbol for factorial is an exclamation mark. So we're going to say %d exclamation mark is equal to %d new line. And the first %d, the first decimal integer, is just going to be n. So what's going to get printed here is n factorial, whatever it was that the user actually entered. And then we're going to get, and let's put a space here for neatness, we're going to say just the answer. We're going to get the answer here, okay? And so now it's kind of like drum roll, please. We're going to compile. So we're going to say GCC O, we're going to say fact test, and we're going to put main.c, and I don't expect it's going to compile first time, but let's give it a try, and I got lucky. Now we're just going to test it with a few values just to see if we get what we think we're going to get. So let's see what we get if we put -1. Error, we can't compute the factorial of a negative integer. That's what we expect. So let's give ourselves some space. We're going to enter, let's say -2. Again, we got the correct behavior. And finally, let's try to trigger another error just one more time. Just -17, and we've got our error message again. So now we're going to try it again, and we're going to do it with 0. See what happens when we get 0. We get 1, okay? Let's see what happens when we put 1. We get 1. What happens if we put 2? We get 2. What happens if we put 6? We get 720, very famously the correct answer. And one that I don't know off the top of my head is 7 factorial. So 7 factorial is 5040 according to our program.